Live from the Key TV studio to your TV and on the web, it's Homework Hotline. Go to homeworkhotline.tv to ask your math or science questions.
Hi, welcome to Homework Hotline. My name is Dan Scofield. I teach science at St. Bernard's Academy.
My name is Alisha Simoni. I teach speech at Alice Birney.
So we are here to answer your science and math questions. So if you want to get in touch with us, go tune your internet device to homeworkhotline.tv, and you can connect up to the live stream that way and ask us questions. And we'd be happy to try to answer. We've got them right in front of us.
I'll be checking.
You can ask away right now. Science and math, you got homework. Maybe you have a question that you're just wondering about, and whatever you want to try, K through college, we'll give it a shot.
Sounds good.
In the meantime, there's something special going on. It's called My Family, My Flavors contest. And do you have a favorite traditional family food? Keat wants you to tell everybody about it. Enter the My Family, My Flavors recipe contest. 3 winners will be chosen to cook their dish on TV and win a $100 grocery store gift card. My Family, My Flavors is open to students between the ages of 14 and 24. If you are under 18, you will need your parent or guardian's permission. Deadline to enter is November 13th. So for rules, details, and entry form, go to keat.org.
That sounds fun.
It does sound fun. So if you have a traditional recipe, I don't know, do you have traditional recipes?
Yeah, I think we do have some.
We do.
Yeah.
1 or 2.
What type of food?
My mother still makes these great rolls all the time. Everybody looks forward to them all the time, every year. It's like the favorite thing that she makes are these special dinner rolls. And she always makes them at Thanksgiving. Anyway, so if you've got a recipe, go for it.
Yeah.
In the meantime, I have some things to show you all about the wonders of water. But in the meantime, I think Alicia's got a little bit of math puzzle for you to take a look at.
Math puzzles are always fun. Okay, so here is our problem this week. We have a little grid, and we're going to find the value of each icon. We have to keep in mind this is a multiplication table, so reading the directions is always important so that you know how to do it correctly. So we're going to just start here in this corner. Whenever you're doing these kind of things, you want to look for things that are simple or that have a lot of information already. So if you have 3 variables there, that's not the best place to start. But here we have 2 that are the same and a number. So we know that volcano times volcano equals 1. And as some of the guys here in the studio pointed out, -1 times -1 could equal 1 because those negatives cancel out. But in this situation, we're keeping it simple, and volcano is equal to 1. So we'll say volcano equals 1, and I'm just going to put them here. Sometimes it helps when you can see it all. And we'll get a different color. Now that we know that volcano equals 1, we can figure out race car because we have volcano times 2 equals race car. So 1 times 2 would be 2. So for the race car, we will fill that in, and I will write R for race car equals 2. All right. Here, this one we can't solve yet because we do not know the Statue of Liberty. But if we come down to this one, we have a 9. Statue of Liberty and Statue of Liberty equals 9. So the square root of 9, or Statue of Liberty times Statue of Liberty equals 9. So that's going to be 3. We'll do Liberty.
Or -3.
This is why we use, or -3, but it won't work for all the equations. We looked. So we'll simplify that for you for now. So we're going to say this is 3 up here, 3 here, and right here. We're getting there. Okay, let's find, I gotta find another color. I'm running out. This rocket ship is next. We can't do this one because it has 2 rocket ships right now. This one we know the Statue of Liberty is 3 times 2. 3 times 2 is 6. So the
Spaceship?
sure, spaceship equals 2 times 3 is 6. 6. This is 6. And over here 6. I just plugged it in for all of those. This is why in math there's a lot of letters. It is holding something, a place value for something. We can do that. All right. So it is, we'll come back to this in a minute. We have a question, so we're going to do that real quick. So x plus 3 is that written correctly? Just want to make sure. I think so. I think we'll just go with that. So for this, you're going to, it's squared. So we want to multiply this whole thing by itself. And in order to do that, we need to do our FOIL. So x plus 3 times x plus 3. And when we FOIL this, I'm going to write that right over here. First, outside, inside, last. So we're going to multiply these two first variables together. So x times x is x squared. All right. And now we are going to do these, outer, sorry. All right. X plus, now these two. Why are you?
X and 3. The 2 on the outside, yeah, those.
Yeah, I was wondering what you're saying. Okay, outside. So these two are the outside over here. These two are the inside. So we're going to do x times 3, and it's going to be 3x. And then we'll do the inside plus 3x.
And last.
And then our last. 3 times 3, it's the last in both sets of parentheses, so it's 9. So we have some common factors here, so we can combine those. So 3x plus 3x is 6x, so we have x squared plus 6x plus 9. And that is your answer. So hopefully that answered your question.
Go ahead and do the.
And we'll just finish this other one before we get to that other question. So, last color, last one. The Ferris wheel. Liberty times rocket, spaceship. Liberty times spaceship would be 18. Because we already have those variables. So that problem is complete also. And I think it is your turn.
Yeah, it's asking for what is.
What does the root word lysis mean?
What does lysis? Lysis means to split open, right, to cut open. It's like to lyse. For a cell to lyse means to burst or to explode. A lot of times it happens with viruses. Will cause a cell to lyse. So something opening. So I don't know exactly what the exact definition of it, but that I think it comes something to do with that lyse.
I was thinking like dialysis or something like that.
Yeah, I mean that's.
But
yeah,
I don't know
yeah,
enough about medical stuff to know
maybe
that.
Check it out. Check it out in my Google, but I know that means. So and so the graphic that's up there right now, yeah, if you put it causes the cell to burst, that would lead to lyse. It would be excess. That's when it's in a hypotonic solution that would cause it to burst. Stuff to flow. If the concentration of water is greater on the outside of the cell, it goes into the cell. If enough of it happens, it'll lyse. All right. Are there any other questions right now?
He said, or it says hydrolysis.
Oh, hydrolysis. Well, yeah, because hydrolysis, that makes sense because hydrolysis, hydro means water. And so in order to split a part. So hydrolysis, condensation reactions or condensation reaction causes water to come out of something and then connect monomers together. And then hydrolysis, you add water to it, hydrolysis, and it causes the larger molecules to break into two smaller molecules. So yeah, that makes sense. So again, it's splitting it into two smaller components, and so that lysis makes sense there as well. So it's to split, I think, is what the root means, but I'd have to take a look at the actual dictionary definition to figure for sure.
Google.
Yeah, there you go. So speaking of water, hey, water, hydrolysis, you add water just to a large molecule, causes it to split into more molecules that take water out of it. It's a dehydration synthesis. It puts them together. I'm going to show you a few things about water today with some activities here. One of them is water has a bunch of properties that are great for living things, and it's caused because of the way they behave molecularly with each other. They have parts that are slightly negative, parts are slightly positive. They tend to be sticky against each other. It causes all these properties that are essential for life. If water didn't behave the way it does, we would not have living things the way they are. One of the things that it does, it causes water to have surface tension, because that air-water boundary, the water gets kind of packed up there, and it has a certain amount of surface tension. And some insects use this to see them skate across the water. And you can actually get a paperclip to float on your water. There's a number of ways to do this. I don't know if we can see this picture, but I do have one floating in this cup. I got it to go after a couple tries, and so I can show you. There's a bunch of ways you can do this. Maybe you can take a hooked paperclip and get it to hang down, or maybe you're super deft with your fingers, and you can which I am not, obviously. And then you can just set it on there and get it to go. But the way that seems to work really well, I've had most success with, is you take a little piece of paper towel and you set it on the water. Oops. You set it on the water, he says. Set it on the water, he says. And then put the paperclip on top, and then it sinks. And then you try it again on top of that. Wait, hold on. Another piece of, I've got little paperclips lined up because I got it to go on the fifth time last time. So we'll see if it does better. Little piece of water. There you go. And then what should happen is the
oh, you
there you go.
got
The
it.
paper towel should sink away, leaving the paperclip floating on the water. Amazingly, in both cases. And so this is the one, you can see it. So it's just floating there. If you're really super cool, you could take the paper towels out and you say, wow, how'd you do that? But that's what I did with this side. And it looks like, you can see it. It's really great. If you really take a look at this, the water looks like it's bending around the paperclip, which is really great. And it works. I mean, it might take a couple tries, and it works pretty well. But again, organisms use this you can actually skate on the water. You can actually use it to if you have your feet are big enough compared to your mass, then you can actually use this to run across the water, which is really cool. Another thing about water is that it absorbs a lot of heat, and it's really great for that. I mean, we are mostly water, which is a good thing, because water takes a lot to change temperature. So you have to add a lot of energy to it. So it's a heat absorber. And it also is a heat retainer. It has what that means is it has high specific heat. And a way to demonstrate that is to burn things, which is always one of my fun things to do. Hey, somebody asked, is this chow again?
Yep.
Chow. What is a macromolecule? Macro means big, right? So macromolecule is a big molecule. In biology, we study 4 different kinds of macromolecules. One of them are proteins, carbohydrates, nucleic acids, and lipids. And so macromolecules, most of them are made up of smaller components that you put them all together and you make these giant molecules that could be thousands and thousands of atoms long. I mean, protein molecules are huge compared to just atoms. They're just big molecules, and they're all joined together by that dehydration synthesis. And so this is an example of one. This one looks like a carbohydrate. So these are 2 simple sugars, left and right, and they're combined together. That middle bond with the oxygen on it is the bond that holds them together, and that bond is created by, if you look at the side of each side, by one of the hydrogens on one of the ends combined to the hydroxide, the OH on the other end, water is lost in the reaction, and it puts the two simple sugar molecules together. This would be a disaccharide. I can't tell what it is right off, but it might be galactose, but I'm not sure. Anyway, I'm not sure what it is. Just looking at it. And then you just, a disaccharide, is like table sugar is a disaccharide. And then sugar is kind of the things that plants make in photosynthesis that is such a great thing for us because they make food and they make oxygen, and I love them for both those things. But they make that for the food for themselves, and then they stick it together in even bigger pieces, so they make building blocks to everything else. And so the macromolecule will be something like they take a bunch of those simple sugars and they turn it even to starch, which can be thousands of sugars long, or cellulose, which they use for their cell walls, and all those different things they put, all made out of simple sugars. So that's a macromolecule. There's like I said, 4 different kinds. Hope that answers the question.
I think it should. That was a lot of information.
Too much information.
Never know. Never
so
too much.
I'm gonna light this candle to show you the next thing. All right. So one of the things we can do to show what water does is to watch what happens. I'm going to try to blow this balloon up about the same size as that one. Maybe a little bigger.
Too big.
Good. Okay. And so I'm going to put this balloon on this candle. What's going to happen, do you think?
It'll get bigger.
You think it'll get bigger
pop?
by just doing it like this?
Maybe.
Gotta see.
Are you going to put a hole in it?
That
Cheese
is
and
not
rice.
surprising.
I didn't think you were going to put it that close.
Okay, so it pops, right? So let's watch what happens now. Now this balloon, I filled. Sorry, Alicia. Should have warned you that it was going to pop. That's like, not surprising. So what's going to
do that
now?
on television.
If this pops, I'm going to set these up here.
No.
Maybe if this pops, it'll not be. It's because what I've done with this one is I filled this part way with water, right? So what's going to happen when I put this here?
I don't know.
You don't know? Okay, let's find out.
It won't because it'll cool it. I don't know. Initially, I was just thinking that are you really going to do that?
Look at this. I'm holding it. It's not. The flame is still lit, right? Mm-hmm. And it's not popping. Eventually, the water will heat up enough that it will. I mean, if you hold this here long enough, the water's going to heat up enough. But what the point is, and if you feel that, just feel the bottom.
Not even warm.
Not even warm. So you can hold this for quite a long time and it won't pop. And it's because of that water having such a high specific heat that all the energy from the flame that's going up into the balloon is being dissipated by the water, because water takes a lot of energy to heat up and cool down. And so that means that's one of the great properties of water, high specific heat. So it will dissipate. I mean, it takes a lot to heat it up, so it won't get very hot. And so the latex next to it won't get very hot. And it ultimately won't burn. And so it's pretty cool. So because of this, we don't change temperature very quickly. Since we're mostly water, it takes a bit for us to change temperature. It helps us keep something called homeostasis, which means we stay at about the same temperature most of the time, unless you're sick. And then it also helps us, like here on the coast, we have this huge body of water, the Pacific Ocean, right next to us, and it regulates the temperatures. Our winters never really get that cold, and our summers never really get that hot. It's because we have this big body of water next to us
Permafog.
Well, we do get permafog. We get fog all the time. We get cold days in the summertime and things like that because of it. But if you go inland, even just a little bit away from the ocean, you have, same latitude, you have extremes in temperature up and down a lot comparatively. So that's another nice thing, that water, again, has surface tension on it. It takes a lot of energy to heat it up and cool it down. And so living things use that for lots of things. Another that's great about water is it dissolves things really easily. It's called the universal solvent. And one of the things you can do with that is to show you that is we get a play. So I'm going to give Alisha some candies.
Oh, I'll take those right here.
That rhyme with fiddles. And we're going to make a design on here. And so this is something you can do. You can do these hard candies, and you can make a nice little design on it. And we can show how water will dissolve things really well. And this is also kind of fun because this is an art project you can do at home. So I'm just taking these these candies and putting them in kind of a little bit randomly, but kind of groups of 3. And then what I'm going to do is pour, just kind of fill some water up with it. Let's see what this does. And I'm going to take this. All right, so Alicia's still working with hers. I'm going to pour mine out. And what you do with this is, a white plate works great, but it doesn't have to be. And what you do is you just fill it up gently to about where it's up. And then I'm going to put these together a little bit. And you can, then you just wait. And this might take a few minutes. Sorry.
Water me, sir.
There you go.
Thank you.
And so you can think of all kinds of designs you can do with this, but already you can see how it's starting to dissolve the outside coating, the colored coating. And then you can make all kinds of art projects with this. You can do Starry Night with this. You can do a scene, whatever you want to do. But it's something fun you can do, and it shows water has this ability to dissolve a lot of different things. And then what we'll do is we'll cut back to this. We'll kind of, as you watch it, actually we see it right now. You can see that the colors are not blending right away. They're staying kind of in their own lanes as it was, and which is kind of fun about this.
I want to swirl it.
And you can kind of see where they're next to each other with the camera shot here, showing that all the colors are not coming together, and they have slightly different properties to them, so they don't come together. Also, I think it's because it's showing diffusion. Diffusion is when things go from a high concentration to a low concentration, and so the dye molecules are spreading out in relatively to the places where they're not. But it's interesting that they don't come together and blend. Which
I appreciate like the stark line.
Yeah, they're really great, and so you can do all kinds of kind of fun things with this about making different patterns. But it shows diffusion, water, whatever the solvent, the solute. Actually, the solute is a candy, and it's flowing. The candy colors are flowing from high to low.
Some of them work better than others too. The orange doesn't seem to work very well.
It's going a little bit. You're right. It looks like the purple and the green are spreading out a lot faster than that. It's interesting that mine aren't going towards the middle, and I think that might be just because my plate might be kind of high in the center. It would be interesting to put one candy in the center and see what it does. I'm just going to do that. Anyway, we'll come back to this in a second. So water dissolves a lot of things, and water doesn't dissolve other things. So if it's like water, if it's something that's called hydrophilic, if the compound is hydrophilic, it likes water. It means water liking is what it means. It will tend to dissolve in it. Other things don't dissolve in water. This is something you can do to make hydrophobic. And things like vegetable oils are made up of largely hydrophobic substances. This is actually for Chow, who was asking about macromolecules. Oils are made up of something called lipids, which are another big molecule, but they're not actually made up of monomers. They're just big, long chains of very hydrophobic materials. And so if we take our water, but anyway, so it's nice pattern going on this one. This is Alicia's candy pattern is pretty cool.
Thanks. Worked really hard on it.
You did. In fact, I love how it's not blending. But and then if we have another.
They have these for the little timers, right? Is that how they do it? It's oil and water where it'll have like red drops drop down, and then you flip it, and then the other side has yellow, and it sinks.
Maybe I haven't seen that, but I was going to get this stuff to
they're
drop.
really
Yeah,
cool. I use them for timers.
Oh, cool. That's cool.
Real quick, I'm going to tell them about my family, my flavors again. So my family, my flavors contests. Do you have a family or a favorite traditional family food? Keat wants you to tell everybody about it. Enter the My Family, My Flavors recipe contest, and 3 winners will be chosen to cook their dish on TV and win a $100 grocery gift card. My Family, My Flavors is open to students between the ages of 14 and 24. If you are under 18, you will need your parent or guardian's permission. The deadline to enter is November 13th. And for rules, details, and entry forms, you can go to keat.org. So check that out.
Cool.
So we have a couple or 1 minute left, so go ahead.
Sure. This is something you can do. You can make your own little lava lamp. What I can do with this too is you could add some dye to this to make it kind of fun. I actually will put a little.
But you can make this.
You can make it swirly and things like that too. You're having some fun over there, I see.
Ooh.
I'm just going to inject that red into there just so we have a little bit more fun with the color. And then what you can do with this is, that was this red food coloring I put in there, but the oil is still on the top. And I can just, if I put a little salt on this, we can kind of interesting things start happening with it.
What?
And so what happens, you got to do it lightly. And what happens is the salt will react with the oil. Anyway,
We'll see you on Tuesday.
We'll show you a little bit more next
Thursday.
time. So anyway, great.